Welcome to part 2 of my easy to understand video on time dilation and the thought experiment of the twin paradox. This part 2 I feel is necessary to be helpful after realizing my first video is not so easy to understand. Here I will clarify for the beginner, explain my thoughts, and expand on concepts from the first video. At 22 seconds, when I say a great percentage of the speed of light, and one travels at a great distance and a great percentage of the speed of light, it can actually be any percentage. It's just that a lower percentage used in this time dilation formula will yield a smaller amount of time dilation. Here, when I say there are many variations on the parameters of this thought experiment, there are many variations on the parameters of this thought experiment. What I mean is that I have reviewed over 20 websites and YouTube videos explaining this thought experiment, and I have studied it for over 20 years. Here, when I say the twins have different names, the twins have different names. We've got Joe, Jane, Terrence, Stellar, Cliff, Biff, Lou, Sue, Alice, Bob, Sarah, Adam, and Albert and Henry. It seems silly that we're trying to learn and fully comprehend the concept of the physics of time, and now we have to remember their names too. The easiest names, I think, to aid in learning are the websites that have Earth Twin, Space Twin, or Homebody and Traveler, or Unprime and Prime, even A and B. We've got Joe. Here, when I say sometimes there is acceleration involved, different names. Sometimes there is acceleration involved. I mean that of the websites I reviewed, some say acceleration is the cause of time dilation. Here is another one. Here, some websites explain the solution both with acceleration and without. This website says it will be left as exercises for the reader. In looking at the history of the twin paradox thought experiment, we find that in 1913, Max van Loo demonstrated that two inertial frames alone are enough to account for the distinctions without having to account for acceleration itself. So the world has known about this for over 100 years. And it's still being presented. When I say the traveling twin travels at different speeds, the traveling twin travels at different speeds. 60, 80, and 99% are popular among the sites I reviewed. Here, when I say sometimes he travels to a star of different distances, sometimes he travels to a star of different distances, between 1/2 and 55 light years are being used by other websites that I've reviewed. One example uses 10 light seconds. When I say we have twin A and we have twin 1, we have twin A and we have twin 1. Easy way to remember that is Earth has the letter A in it. And think of spaceship 1. Here, when I say he sees older and older information, that as twin 1 is getting farther and farther away, if he looks behind him, he sees older and older information. This is called the relativistic Doppler shift. And when I say on the way back, or on the way back home, I should have said on the way out. When I say I added another planet in the same frame of reference as the Earth, I have added another planet that is in the same reference as the Earth. I did this to make a distinction, and that is all the different points of view. In this animation, we see the traveling twin's point of view. The twin is not moving. The Earth is moving. And you have no point of view because you are in the same frame of reference as the ship. Your point of view is the same as the traveling twin. In this animation, we see the homebody twin's point of view. This twin is not moving. The ship is moving, and you have no point of view because you are in the same frame of reference as the Earth. Your point of view is the same as the homebody twin. And in this viewpoint, we are at an infinity distance away. I call this God's point of view. You can see both twins' points of view, switch between each one, and see that the light is connected to both. This viewpoint is you in your imagination. Listen to this statement. It's a little confusing. Space. This is the reason why the twin who is traveling a percentage of the speed of light and comes back ages less, because he has to get back to the Earth that all the light was destined to get to in the natural course of time for the Earth. What I knew in my imagination from the infinity point of view is I can be with twin A's aging and see light going into the Earth while seeing that twin 1's aging appears to be slower because he is missing some of the light coming to him from different directions. Here, when I say in this animation we are launching 7 twins, in this animation we're launching 7 twins, I should have said octuplets 1 through 7. Here, when I say the ages of twin 1 and twin 7, through them, twin 1 will have aged only 8.72 years, and twin 7, at 30% the speed of light, will have aged 19.08 years. Here are the correct numbers. Octuplet 1 would be 9.69 years, and octuplet 7 would be 63.59 years old. Here, when I say this is my light clock animation, I mean that the light goes from here to here, then back up in here, back and forth. I added this other planet, which is just a marker to show when the light from this light clock reaches the top. Here is another example of a light clock. Think about this. A light clock can be any size, light years tall, as the scale of my animation suggests, normal clock size, or atomic size. Consider that every atom has light going into and reflecting or coming off of it constantly. Here, when I say a triangle is created, a triangle is created up to this. And here we see the outline my light clock has made. When we split the triangle in half, we have a 90-degree right triangle. Here, when I say we know that the speed of light is a constant for everybody from all directions, we know that the speed of light is constant for everybody from all directions. Now is a good time to point out Einstein's 2 postulates, and that is 1. The laws of physics are the same from everyone's perspective in uniform motion, and 2. The vacuum speed of light is the same for all observers. That is 299,792,458 meters per second. Here, when I say this length is longer, from the Earth's point of view, this length is longer. What I mean is from here to here is the hypotenuse of the triangle, which is longer than this length. Here, when I said we know these distances are the same, what I meant was this distance is the same as this distance, but that's not important. What I should have said is this longer distance is the same light as this distance, but as measured by each observer, it takes the same amount of time. Here, when I say we come up with my formula, I was trying to make it easy in that the 1 in this formula means 1 second, 1 year, or 1 unit of our time, the time of twin A on Earth. The formula is truly this, with the t being the time of twin A, and v meaning the velocity or the speed of light expressed as a percentage, and the t prime is the time of twin 1, the traveling twin. Please visit my website, scott.teee.tv.